The universe is vast, mysterious, and filled with secrets that defy our understanding. For centuries, humanity has looked to the stars, to the fabric of reality itself, and asked questions that seem to have no answers. What is the true nature of the cosmos? Why does it behave the way it does? And perhaps most unsettling of all, why do the very laws that govern existence seem to hide their deepest truths from us? These are not just questions for scientists. They are questions that strike at the very core of what it means to be human. They force us to confront the limits of our knowledge, the fragility of our understanding, and the possibility that the universe is far stranger than we could ever imagine. At the heart of this mystery lies physics, the science that seeks to explain the fundamental workings of reality. Physics has given us incredible insights into the nature of light, the structure of atoms, the forces that bind the cosmos together. It has allowed us to harness energy, to explore the depths of space, and to glimpse the origins of existence itself. And yet, for all its power, physics remains incomplete. There are questions it cannot answer, mysteries it cannot solve. These are not just gaps in our knowledge. They are chasms, vast and deep, that threaten to swallow our understanding whole. One of the most profound of these mysteries is the nature of dark matter. Every galaxy we observe is surrounded by an invisible halo of something that exerts a gravitational pull but emits no light, no radiation, no signal of its existence. We know it's there because we can see its effects: stars orbiting galaxies faster than they should, galaxies moving in ways that defy the laws of gravity as we understand them. And yet, despite decades of searching, we have no idea what dark matter actually is. Is it a particle, a field, a shadow of some higher dimension? We don't know. What we do know is that it makes up roughly 85% of all matter in the universe. That means the stuff we can see, the stars, the planets, the galaxies, is just a fraction of what's out there. The rest is hidden, shrouded in darkness, waiting to be discovered. But dark matter is just the beginning. There is also dark energy, an even more enigmatic force that is tearing the universe apart. In the late 1990s, astronomers made a shocking discovery. The universe is not just expanding, it is accelerating. Some invisible force is pushing galaxies apart faster and faster, overpowering gravity itself. This force, this dark energy, makes up about 70% of the universe's total energy content. And yet, like dark matter, we have no idea what it is. Is it a property of space itself, a new kind of energy field, or something entirely beyond our comprehension? Whatever it is reshaping the cosmos, driving it toward a future that is as uncertain as it is inevitable. Then, there's the mystery of matter and antimatter. According to our current understanding of physics, the Big Bang should have created equal amounts of matter and antimatter. And yet, when we look around, we see a universe filled with matter. Stars, planets, galaxies, and almost no antimatter. Why? What happened to it? Why does matter dominate the cosmos? This imbalance, this asymmetry, is one of the greatest unsolved problems in physics. Without it, the universe as we know it would not exist. And yet, we have no explanation for why it exists at all. These mysteries are not just academic curiosities. They are fundamental to our understanding of reality. They force us to confront the limits of our knowledge, to question the very foundations of our scientific worldview. And they remind us that, for all our progress, we are still just scratching the surface of the universe's deepest secrets. But perhaps the most unsettling mystery of all is the incompatibility of our two greatest theories of the physics, quantum mechanics and general relativity. Quantum mechanics describes the behavior of the very small, the world of atoms and particles, where probabilities rule and nothing is certain. General relativity, on the other hand, describes the behavior of the very large, the world of stars and galaxies, where gravity bends space and time itself. Both theories are incredibly successful, accurately predicting the outcomes of countless experiments and observations. And yet, they are fundamentally incompatible. They cannot both be true. At some level, one or both of them must break down. This incompatibility is not just a theoretical problem, it is a practical one. It means that we cannot fully understand the universe's most extreme environments. Black holes, the Big Bang, the very fabric of space and time itself. It means that our understanding of reality is incomplete, that there is something fundamental we are missing. And until we find a way to reconcile these two theories, until we find a theory of everything, we will remain in the dark. But the mysteries of the universe are not just scientific, they are deeply human. They remind us of our place in the cosmos, of how small and fragile we are in the face of such vastness. They force us to confront the limits of our understanding, to question our assumptions, to wonder if we will ever truly know the answers. And yet they also inspire us. They drive us to explore, to discover, to push the boundaries of what we know. They remind us that the universe is not just a place of darkness and uncertainty, it is also a place of wonder, of beauty, of infinite possibility. So as we look to the stars, as we probe the depths of space and the secrets of the atom, let us remember that the mysteries of the universe are not just problems to be solved. They are invitations to wonder, to explore, to dream. They are reminders that no matter how much we learn, there will always be more to discover. And they are proof that, in the face of the unknown, the human spirit is boundless. The universe is vast, mysterious, and filled with secrets, but it is also ours to explore, to understand, to marvel at. And in that exploration, in that search for answers, we may just find something even more profound: ourselves. The universe is a tapestry of wonders, woven with threads of light, energy, and matter. Yet for every thread we see, there are countless others hidden in the shadows, waiting to be unraveled. Among these hidden threads lies the enigma of quantum entanglement, a phenomenon so bizarre that even the greatest minds of the 20th century struggled to comprehend it. Imagine two particles, separated by vast distances, millions of light years even, yet somehow intimately connected. Change one, and the other changes instantaneously, as if space and time themselves are irrelevant. This spooky action at a distance, as it was once called, defies our classical understanding of reality. It suggests that the universe is far more interconnected than we ever imagined, that there is a deeper layer of existence where the rules of cause and effect, of locality and separation, no longer apply. And yet, despite decades of experiments confirming its reality, we still don't fully understand how or why it works. Quantum entanglement is not just a curiosity, it is a window into the fundamental nature of reality, a glimpse of a universe that is far stranger, far more mysterious than we ever dared to dream. But the mysteries of the quantum world are not confined to entanglement. There is also the puzzle of wave-particle duality, the idea that particles like electrons and photons can behave as both particles and waves, depending on how we observe them. This duality lies at the heart of quantum mechanics, and yet it raises profound questions about the nature of reality. What does it mean for something to be both a particle and a wave? What role does the observer play in determining the outcome of an experiment? And perhaps most unsettling of all, what does this say about the nature of existence itself? These questions have no easy answers, but they force us to confront the possibility that reality is not as solid, as objective, as we once believed. Instead, it may be fluid, malleable, shaped in part by our own observations and expectations. Beyond the quantum realm, there are even greater mysteries waiting to be explored. One of the most tantalizing is the nature of black holes. These cosmic behemoths, born from the collapse of massive stars, are regions of space where gravity is so strong that nothing, not even light, can escape. They are the ultimate expression of Einstein's theory of general relativity, and yet they also pose some of the greatest challenges to our understanding of physics. What happens to matter that falls into a black hole? Does it vanish forever, or is it somehow preserved? And what lies at the center of a black hole, in the region known as the singularity, where the laws of physics as we know them break down completely? These questions are not just theoretical. They touch on the very nature of space, time, and existence itself. Recent discoveries have only deepened the mystery. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's shadow, a monumental achievement that confirmed many predictions of general relativity, but it also raised new questions. For example, why do some black holes emit powerful jets of particles traveling at nearly the speed of light? What is the source of these jets and how do they form? And what can they tell us about the nature of black holes themselves? These are questions that scientists are only beginning to explore, and the answers may hold the key to understanding some of the universe's deepest secrets. But black holes are not the only cosmic mysteries. There is also the puzzle of fast radio bursts, FRBs, brief but incredibly powerful bursts of radio waves that come from distant galaxies. First discovered in 2007, FRBs have puzzled scientists ever since. What could produce such intense bursts of energy, often lasting just milliseconds? Are they the result of cataclysmic events, like the collision of neutron stars or the collapse of massive stars? Or could they be something even more exotic, like signals from advanced extraterrestrial civilizations? While most scientists favor natural explanations, the truth is that we still don't know. FRBs are a reminder that the universe is full of surprises, that there are phenomena out there that defy our expectations and challenge our understanding. Closer to home, there is the mystery of the solar system's formation. While we have a general understanding of how the sun and planets formed from a swirling cloud of gas and dust, many details remain unclear. For example, why do the planets have the compositions and orbits they do? Why is there so much water on Earth and so little on Venus or Mars? And what role did chance play in shaping the solar system as we know it? These questions are not just academic. They have profound implications for our understanding of life's origins. If the formation of the solar system was a random process, then Earth-like planets may be rare in the universe. But if it was governed by deeper laws, then planets like ours, and perhaps life like ours, may be common. The search for answers to these questions has led scientists to explore not just our own solar system, but distant star systems as well. In recent years, the discovery of exoplanets, planets orbiting other stars has revolutionized our understanding of the cosmos. We now know that planets are common, that they come in a staggering variety of sizes and compositions, and that some may even be capable of supporting life. But with this knowledge comes new questions. What conditions are necessary for life to arise? Are there other Earth-like planets out there, with oceans, atmospheres, and perhaps even civilizations? And if so, how can we find them? These are questions that drive the search for extraterrestrial life, a search that is as much about understanding ourselves as it is about understanding the universe. But perhaps the greatest mystery of all is the nature of consciousness itself. Why are we aware? Why do we experience the world as we do, with thoughts, feelings, and perceptions? And how does consciousness arise from the physical processes of the brain? These questions lie at the intersection of physics, biology, and philosophy, and they challenge our understanding of reality in profound ways. Some scientists believe that consciousness may be a fundamental property of the universe, like space or time. Others think it may emerge from complex interactions within the brain. But the truth is that we don't know. Consciousness remains one of the greatest unsolved problems in science, a mystery that may ultimately reveal as much about the universe as it does about ourselves. As we continue to explore the cosmos, to probe the depth of space and the secrets of the atom, we are constantly reminded of how much we have yet to learn. The universe is vast, mysterious, and filled with wonders that defy our understanding. But it is also a place of infinite possibility, a canvas on which we can paint our dreams, our hopes, our questions. And in that exploration, in that search for answers, we may just find something even more profound, the truth about who we are and our place in the cosmos. The mysteries of the universe are not just problems to be solved, they are invitations to wonder, to explore, to dream. They remind us that no matter how much we learn, there will always be more to discover. And they inspire us to keep searching, to keep asking questions, to keep pushing the boundaries of what we know. For in the end, it is not the answers that define us, but the questions we dare to ask. And in those questions, in that search for understanding, we find the true essence of what it means to be human. The universe is a realm of infinite complexity, a cosmic puzzle that continues to defy our understanding at every turn. Among its many mysteries, one of the most perplexing is the nature of time itself. Time, as we experience it, flows in one direction, forward. We remember the past, but not the future, and we cannot undo what has already been done. Yet the laws of physics, as we currently understand them, are largely time-symmetric. They work just as well whether time moves forward or backward. So why does time have a direction? Why does it flow the way it does? This question, known as the arrow of time, has puzzled scientists for centuries. Some believe the answer lies in the second law of thermodynamics, which states that entropy, a measure of disorder, always increases over time. Others think it may be connected to the expansion of the universe, or even to the nature of consciousness itself. Whatever the answer, the arrow of time is a reminder that the universe is not just a place of space and matter, but also of change, of evolution, of history. Another profound mystery is the nature of the vacuum of space. To the naked eye, space appears empty, a vast void between stars and galaxies, but in reality, it is anything but empty. According to quantum field theory, space is filled with a seething, bubbling froth of virtual particles that pop in and out of existence in fractions of a second. These particles are not just theoretical, they have real effects, such as the Casimir effect, where two uncharged metal plates placed close together in a vacuum experience an attractive force due to the fluctuations of these virtual particles. But what is the true nature of this quantum vacuum? Is it truly the lowest energy state, or could there be something even deeper, something we have yet to discover? And what does this mean for our understanding of space, time, and the very fabric of reality? These are questions that challenge our most fundamental assumptions about the universe. Then there is the mystery of the multiverse, the idea that our universe may be just one of many, perhaps even an infinite number, has gained traction in recent years, fueled by theories like cosmic inflation and string theory. According to these ideas, our universe may be just one bubble in a vast cosmic foam, each bubble with its own laws of physics, its own constants, its own history. Some of these universes may be similar to ours, while others could be wildly different, with different dimensions, different forces, even different forms of life. But is the multiverse real, or is it just a speculative idea, a way to explain the apparent fine-tuning of our universe without invoking a creator? And if it is real, how could we ever detect or interact with these other universes? These questions push the boundaries of science and philosophy, forcing us to confront the possibility that our universe is just a small part of a much larger, much stranger reality. Closer to home, there is the mystery of the moon's origin. While the prevailing theory is that the moon formed from the debris of a massive collision between Earth and a Mars-sized object early in the solar system's history, there are still many unanswered questions. For example, why do the Earth and Moon have such similar isotopic compositions, as if they were made of the same material? And why is the Moon's orbit so perfectly aligned with Earth's rotation, a coincidence that seems almost too perfect to be random? These questions have led some scientists to propose alternative theories, such as the idea that the Moon formed from a series of smaller collisions, or even that it was captured by Earth's gravity after forming elsewhere in the solar system. Whatever the truth, the Moon's origin is a reminder that even the most familiar objects in the night sky can hold profound mysteries. Another cosmic puzzle is the nature of gamma-ray bursts, GRBS, the most energetic explosions in the universe. First detected in the 1960s, GRBs are brief but incredibly powerful bursts of gamma rays, often lasting just a few seconds. They are thought to be caused by the collapse of massive stars or the merger of neutron stars, but the exact mechanisms are still not fully understood. What makes GRBs so intense? How do they produce such enormous amounts of energy in such a short time? And what can they tell us about the extreme conditions in the early universe? These are questions that scientists are only beginning to answer, and the answers may shed light on some of the universe's most violent and mysterious events. But perhaps the most tantalizing mystery of all is the possibility of life beyond Earth. In recent years, the discovery of potentially habitable exoplanets has fueled speculation that we may not be alone in the universe. Planets like Proxima Centauri b, located just 4.24 light-years away, and the TRAPPIST-1 system, with its 7 Earth-sized planets, have raised hopes that we may one day find evidence of extraterrestrial life. But what would that life look like? Would it be similar to life on Earth, or something entirely different? And how would we detect it? These are questions that drive the search for biosignatures, chemical signs of life, such as oxygen or methane, in the atmospheres of distant planets. But even if we find such signs, how can we be sure they are the result of life and not some non-biological process? These are challenges that scientists are only beginning to grapple with, but they are challenges that could ultimately redefine our place in the cosmos. The universe is a place of endless wonder, a realm of mysteries that challenge our understanding and inspire our imagination. From the quantum realm to the farthest reaches of space, from the nature of time to the possibility of life beyond Earth, the questions we face are as profound as they are perplexing. But they are also invitations to explore, to discover, to dream. They remind us that the universe is not just a place of darkness and uncertainty, but also of light and possibility. And they inspire us to keep searching, to keep asking questions, to keep pushing the boundaries of what we know. For in the end, it is not the answers that define us, but the questions we dare to ask. And in those questions, in that search for understanding, we find the true essence of what it means to be human. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up